That's cool. You can see the shader reflection. That's cool. Excellent. Excellent. Whew. Oh, I've had so many moments where I've thought about the stream title, the the bike chain shape where it goes around a small circle and a big circle. I think I'll start simple. Starting simple is very difficult for me. I'll probably not start simple. Oh, sure. Uh, two circles. So, um, okay, I'll draw it. I'll draw it. I'll draw it. Okay. So here's what I want to make first. New. Uh, so I want a big circle and a little circle. And you may notice that this doesn't really work. You can't just go here to here and here to here halfway across the circles because you get this wonky shape. You have to like find the tangent line of the circle that like aims at the tangent line of the smaller circle to get that shape. But I think I want to start with this because I think I can morph it into the other one. So here's what I'm gonna do. I'm gonna like make this, and I'll have a big old triangle right here. Wet, 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 and then we can have another triangle here. Ugh. Boom, boom, and then more triangles going down. So triangle, triangle, triangle. It already looks like a triangle. Uh, 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 uh. So that's what I'm going to start with. I'm going to try and do that. Well, okay, so one thing is I also need to do this. So this needs to be a triangle, that needs to be a triangle. So I have one here, one here, one here, one here, one here, one here. And I'll probably subdivide one more time. Is that 24? Well, no, it's not 24 anymore. It's power of 2. It's on my face. There's something there. I don't know. Okay. Now, maybe time. Uh-huh. Hmm. Hmm. Oh yeah. Um, I thought of a way to do less. N layers. Hmm. Um. Huh. All right, it's like not a big deal. I'm thinking I can avoid calculating the sine again. I'm like generate 4 vertices at once, going around the circle a quarter turn. And that would work. I could just go like this, divide 4, and then boom, boom, boom. And then this would be plus n over 4 times 2 times 3. And then I would just swizzle, like this is negative, and then this is like okay. Haha, yes. It'll be like this. Dot x offset dot y. Okay, so we're starting at x equals 1, y equals 0, and going towards positive y. So the next one has to be starting at y equals 1, x equals 0, and going towards negative x. So that's like this. Negative and positive. And then this is just straight negative. And then this, by definition, will be the negative of that. And like that should work. So this does like 1/4 of the number of sine and cosine calls. Which should be faster, but it doesn't matter in the slightest. I don't know why. I'm so obsessed with like shift, doing powers of 2 as shifts. The compiler should be able to see through it regardless of what I do. And like choose the best operation. Hmm. Hmm. Oh, let's see if it works. Fun stuff, right? Hmm. Hmm. So this stops working if I lower the layers, but I'm not gonna lower the layers. Hmm. Oh. Model 94. Hmm. Okay. Right. Right. I remember. Okay, so I built it. Yep. All right, let's see what happens. So the circle should still be generated correctly, but just more efficiently for no reason. Cool. And then there's no change to the other one. Okay. So this is do less sin. And then We can put this on min diff here. Sick. Okay, and then ugh. Okay, what's the number? 1. Okay, let's look at the diagram. So 1, 2, 3, 4, 5, 6, 7. Is that's 2 layers. And I wanted 3 layers, right? So then, okay, well this is a little bit more compact, because like it's like a square instead of a, excuse me, circle or a triangle. Because like if the circle would go over here and that's a square. Okay. So so 1, 2, 3, 4, 5, 6, and then plus 8. 1, 2, 4, 8. 1, 2, 4, 8. 2, 4, 8. That's 3 layers. So that's the number of word primitives. That'll be 15. So 15, 15 plus 2 is 32. So we should have 32 primitives total. And and then how many vertices? How many? We start with 3, and then subdivide 3 plus 2 plus 4 plus 8. Times 2 plus 2. Yeah, math. So this is 16. No, this is 17. Wait. No. There's no plus 2. It's just 2 times 17, which is 34. Am I dummy? What did I? Is this? What happened here? Okay, whatever. Am I dummy? Did I not just write that? Why did it say 2 times 4? 24. Okay, and then I said this is 34. Okay, so I'm not entirely stupid. I'm curious actually. If this is different, does that change the way things are? You can tell because of the way it is. Right. Okay, so an edge we're looking at. It does not change the way things are. I need to change the way things are. That's my job. So we're going n divided by 2 here. And this we just steal these numbers. These are the numbers. Those numbers are the numbers. Where did I go? Whoop. Primitive count. Bow. N. Wait, plus 2? Wait. Vertices, primitives. Vertices, primitives. Primitives is plus 2. I wrote the numbers completely backwards. Primitives is 1 plus 2. Vertices is 3, 2, 4, 8. Okay. I'm glad I caught that, because that just silently fails. Okay. Oh my god, bro. Oh my god, bro. So we're gonna generate the left circle and the right circle at the same time. Like so. Yeah. Okay. Isn't that grand? So this is 2 half circles that make a whole. Wait a second. Oh. I do actually need a plus 2 vertex count. I'm stupid. Okay, so that's where the 3 came from. Am I stupid? What? So this is like wrong. I don't know. Just smash. I'll just add 2 here, or 1, I guess. Wait, plus n over 2. Jesus. Okay. So we're gonna go up 2. So it's going to go like this. And it includes the final vertex. It goes like, I've done it hugely wrong actually. I'm going like this. Um ah. I'll just pretend that I did it right and move on to the next stage. Oh my god. So max area triangle indice triangle once again. So the steps are the same for both. It's just the count is unknown ish. But it's not. It's the count is n minus 2. Okay, but that's for the other one. The the triangle. The triangle. N divide by count. Count equals n. I less than count. So this is 24. We want it to be 12. And we only need to do one run. We can just do both of them in one run. So it starts at 12. And then we divide count by 2. So now it's 6. So now we have n divided by 6. No, we want n divided by 2 divided by 6. And this does not wrap ever. There is a final vertex. There's no modulo. So I think that's it actually. And then I can go like this, and then I can go like n over 2 plus 1 plus I. No, not correct. Oh, I need both of these. Who is this? What is this? What's happening? How many one plus 2. There's 15 triangles each. But then we have one extra. So there's 16. So this is triangle 16. How do we know it's 16? Can we know layers? 3. 2 to the power of 3. Is a number. 2 to the power of 1 is 2, 4, 8. So it's layers plus 1 minus 1. Can I use that plus 1, not minus 1, because it's plus 2. So it's like this. 15. That's primitive. That's triangulars. Yeah, no, that's it. Very confusing. Wow. And then that ought to do it. Oh, look, it's the same. Oh yeah. Okay. So. Uh. Uh-huh. And then this, you have to add. Uh. Am I stupid? I didn't add something dumb, right? Base plus I n vertex count. I think I checked that before. Okay, so indices is n over 2 plus 1. Um. Uh-oh. This is the 1. So this is Oh, I can do this any way that I want. I should probably smush them together. I don't know. I'm gonna heat this up. I'll be right back. Oh. So all of these n's are n over 2. N over 2. Oh. Yeah, no, this is no. This is n over 2. N over 4? And now there's 2 triangles missing. The big triangles between the circles to do. All right, let's see what happens. I think it's gonna look awful and not even close to anything resembling what I want. But it will maybe draw something, maybe. Oh, cool. It maybe draws something, maybe. So we have like little bits around there and little bits around there. And no filler triangles. This is about what I expected. So like if you look at this, it's still the same orientation. I mean, honestly, I understand what it's trying to tell me. It's trying to tell me that that edge is right there. What if I go like, yeah, look at one is bigger than the other. Okay, what about this guy? Oi, oi. If I go like, oh, it's way small. Huh. Yeah, it was way over here. Damn. Okay, working real good. Okay, so it's doing what I want, but I haven't drawn the shape correctly yet. It is going to be a challenge. Work on bike chain. This is honestly better than what I had before. I can actually like see both ends of the edge, so it actually conveys the information about which edge is the closest edge. Buh. Buh. Vector. I need to vector. Is it a linear space? Why is the music so loud? The position here, it's a vec4. The first component is like x. Second component is y. The third component is like depth from the screen. And the fourth component is w, which is sort of a scaling factor. That's you take those three components and you divide it by w. I think it is linear, right? It's a linear transformation because you just do the camera projection. But does it work with like an ideal point? If I subtract these two positions and then like do the unit, and then like swap the x and y with one negative, to get a perpendicular vector to make my little circle oriented, what would happen? So I'm adding 0. I'm adding 0. I'm adding 0. Yes. So what was happening before is I was working in like world size, basically. So like it's screen space, but world size. So 1 unit of offset added to this pixel is not 1 pixel. It's 1 world unit. So like, yeah, I can just run it as is. So like this, it gets smaller as I go farther away, and it gets larger as I get closer, exactly in proportion with world units. These units are world units. Are you moving from Roblox? I just did. Well, let me hear about it. What do you mean? What do you mean by that? Working on in Unity. I am working. This is a work stream, so no. But I want to hear about going away from Roblox, because that's kind of what I'm doing as well. But it's not like I just did. It's like I've been working on this for 2 years. They cannot protect children. Damn. Yeah, it's kind of a surprise that Roblox didn't have a scandal for such a long time. They just kind of glided through. So I've failed to make my half circles correctly. I appear to have vertices of some kind. And my triangles, the half triangles look good. But then these ones are the big wrong. Count. Yeah, no, we're not in thirds anymore. It's 13 vertices. There's 13, right? 13 vertices. It's like one every half hour. 1, 2, 3, 4, 5. There's 12 to like here, and then 13 is straight down. Have you tried raycasting? Yes, actually. You can see that it's highlighting like where the mouse is at the center of the screen. This is a custom game engine that I wrote from scratch. So this debug visualizer is displaying the close. Okay, let me get my wording here. I wrote some graphics code that displays the face, edge, or vertex containing the closest point to the character highlighted on the mesh under the cursor. So whichever mesh I point at, it highlights what the closest point on that mesh is to me. So on this one, it's the edge there, and I'm working on the rendering for that to like highlight the edge. It's not working yet. That's what the bike chain idea is. I'm gonna have this like series of polygons, and like, so if I'm like looking at the edge like this, then it's gonna have a big circle and then a small circle, right? In like screen space. And so it'll be like a bike chain. That's what I'm working on, and you can see it's I don't have it working quite yet. Like if I look at this one, if I go over here, this one is big, that one is small. You can see it right over there. Ooh. What? That was a physics bug. That's what I'm trying to fix, is the physics bugs. I'm making this face edge or vertex visualizer so that I can observe the physics code running visually, and then look, I just fall through the ground. Bruh. I made it in a day. Isn't that nice for you? I'm over here making everything from scratch. Like, remember how I said I had ray tracing? Well, how do you think I did that? Where is it? Where is it? Trace ray. So here's the code. Trace ray. So this is the physics data. That's like all the meshes that exist in the world. And then you have your ray, and that's like the origin and direction, right? Good, good, good. And then I instantly call this sample ray function. Oh, well, what's that? Definition. Oh. So this algorithm, I feel like I should be able to explain it in one sentence, but anytime I try to formulate it, it's like multiple paragraphs. So if you're tracing array, you could just like test every single object in the world and just check every single object, right? Test that one, test that one, test that one, test that one, test that one. But like that would be really slow. I wouldn't be getting 1,500 FPS if it was doing that, right? Differentiation in pixels. No. So what I have is a spatial index of which objects exist where. So like in this area, let's say that on the left half there's a box around everything in there, and on the right half there's a box around everything in there, and then I have a greater box that surrounds everything. And so at the lowest level you have each object, and then you have a box around that, and you know everything is inside that box, and then you have the objects over here, and you have the box around that. It forms a hierarchy, a tree of boxes. So what I can do, if I'm trying to find something in the world, I can start at the biggest box, that the whole world is inside the biggest box. And am I inside that box? Yes. So then now I look inside that box, and there's two boxes, one on the left, one on the right. And am I inside this box? Yes. Am I inside this box? No. I can ignore half the world. So immediately I don't have to check half the world. That saves a lot of computing, right? So then now, am I inside this box? Yes. So now I only have to check two objects, only the ones that are close by. So in the whole map, there's this like hierarchy of boxes of what is inside of what, and I like descend down this bounding volume hierarchy to locate objects in the world. So it's a data structure that locates objects. So that's what BVH is. Self is BVH. So it's a spatial index of where objects exist. So how the ray trace works is I have a starting point for the ray, right? The ray has an origin and a direction. So the first thing I need to do is find out where that starting point is. So I dig down into the boxes and test anything that's like right there. Is your Roblox account quaternions? Yes. And then I like there's this like map of the future. Oh, really? So this is a sorted list. It's a fast sorted list of anything that the ray is going to intersect with in the future in the order that it will intersect with it. So I construct this list of what's in the current box that I'm going to intersect with in the future. And then I start going through the list while pop the first element off the list. Okay, so the first element that's off of the list is a box that I'm gonna hit. If it has an object in it, then test collision against that object. Otherwise, break open the box, see what's inside the box, and like add the time of intersection to the list. It's complicated, and it doesn't even fully work correctly. But it works pretty good. Does it have to do with a pre-mapped thin thing with all vertices? Yeah, so I have a whole ray tracing algorithm written from scratch that doesn't work perfectly. Whereas in Unity, you can just do like trace ray, and it just goes off and does it. So yeah, if you want to make a game, use a game engine. If you want to learn about how game engines work, make a game engine. And that's why I'm doing this, is because I'm here to learn. Making a game is kind of secondary. Could you remake Roblox? It would take me years and years and years, but I kind of already have. Within my project, I have this library, Roblox emulator, and watch this. Get Roblox emulator CLI run script. All right, so this is a script. Let's look at the script. I'll open it in my editor. So here's a script, right? This is a Lua script. Wow, it's a Lua script. Why don't I make my screen bigger here? Scale 3. So I have a function. It's like converting a matrix to axis angles, but this is a Roblox function, right? C-frame matrix components, C-frame from Euler angles. So this is a Roblox script. But with my thing here, I can run my Roblox emulator, run a script, and here is the script to run. And it runs it, and it prints the result. So I already have made a Roblox emulator, and like it'll run. So like I have find first child, right? And so when you call part find first child, it actually goes and calls this function. So I'm like pretending to be Roblox. I'm replacing the Roblox functionality that the script expects to exist. Can I see it in action? That was the action. So why did I make this? Well, it's for bhop maps. So this map ISO, if I run the map without, oh, where is it? Can I even do that? Can I even disable the Roblox emulator? Let me see. Okay, let me try. It's been a while since I've not used it. I should test some specifics on how accurate that emulator is. Think I've looked at it closely yet. I did a pretty good job of making a large majority of map scripts work. If you try to use it as a runtime, it will memory leak, mainly because of this, the instance value store. Wait, any user data? What the heck? So when you connect to a Roblox script signal, so like game get service run service dot render step connect, that's connecting to a script signal. That is implemented using this because the document object model, that the like properties tree, the object tree, like the workspace, the objects don't have the metadata attached to them. So this is kind of like attaching a script signal to a part or a service or something. And like it would be better if they were owned by that, because like otherwise they need to implement garbage collection. I just don't want to do that. I have plans to like rewrite a bunch of stuff with the Roblox data object model, the file decoder. I love this library. It's so fun to work on this library. Look at this. I have opened like 20 pull requests because I just can't stop working on this. C++ question mark. What does colon mean and question mark in C++? Are you just actually asking? I used it for if statements, but I don't understand it. This is called a ternary. I know. It's called a ternary operator. Let's just write it here. So we have a function f. Wow, it's a function. Is good equals true. So we have a bool value, and then we have two other values, x equals 4, y equals 6. We can call this use y or something. So in C++, you could write use y question mark y colon x. And that means if use y is true, use y. Otherwise, use x. So that's the ternary operator in C++. You can see that this is a syntax error in Rust. In Rust, you would write if use y, else x. If statements in general are the ternary operator in Rust. In Rust, every single block can implicitly return a value. So that's what's going on here, is this OK function. This is the return value of this function. So it's as if I typed return like that, which is interesting. So that's what it is. Value equals exactly. That is exactly the same thing in Lua. but simpler, but more concise. Uh-oh. Yeah, the Roblox emulator is pretty cool. Look, there's all the things I support. Create script signal. Touch ended. Basically, the extent of the support is that the script won't error when it runs, and not that it actually works. Yeah, the Roblox emulator is fun. Let's see if I can disable it. Okay, so the Roblox loader reads Roblox maps using this file decoder. So do you know like RBXM files? This is a decoder for the actual files that's written in Rust. So it takes the RBXM file and decodes it, and then you can like look at all the parts in Workspace and stuff. And so that's a dependency of my Roblox loader. And then I like look through all of the objects, and do I have a feature? No, I don't. I like look through all the objects and decide what is a bhop platform and like what is a start zone, and then like convert that into my game engine. Roblox emulator. Where do I run it? Runner new. Find references. Run scripts. So if I just comment out this line, oh no, it's not gonna like that. Oh, that's the map tool. Wait. Oh, does it not run scripts? Oh, that's right. Oh, okay. So right. I remember now. Okay. So I have a conversion tool called this map tool that takes the Roblox file and converts it into a strafe client file, a sniffm.snfm, and that runs the scripts. But I can also read the scripts or like features Roblox. So I'm enabling Roblox support for my game engine right now and recompiling it. You can see there's way more dependencies, like 100 extra dependencies to do this. And I can then load the RBXM file and generate the bhop map that the game engine can understand. And it doesn't run the scripts. Whereas the one I was already loading was pre-converted by the map tool ahead of time. I did it a while ago. And I ran all of the scripts that clean up the map. Okay, so now if I run this, okay, so what map ID is this? All right, so we can just like run it kind of like this. Strafe client, except now I need to like enter in the map. The map. Where is it? Is it here? Yes, it is. Maps. bhop. Okay, we're in. Map is this map. Let's find that map. Oh no, I wanted ISO. Dang, okay. ISO. Because it's very obvious when the scripts don't run. It's very obvious. Okay, so let's copy this. And we're going to run the game engine and load this file. I don't think the textures will work. Uh-oh. Oh. Unicode aware. This is regex. I have just run into a regex error. Oops. Oops. Regex. What feature? Haha. Regex. All right. What? What? Wait. Oh, archive. Why didn't it find this? Okay, I have to fix this bug before we can convert the map. There it is. That's what I wanted. Okay, so then the Roblox loader needs this feature. That should fix it. Rebuild. Why is regex unhappy about that? Basically, I disabled all of the features, and it was using a feature that was disabled. Okay, let's try that again. So I'm running the game engine with a Roblox file as input, and it should dynamically convert the file. Oh, wow. It did a really good job. Damn. I didn't expect the textures to work. So where's the checkpoints? Okay, I actually need to commit this. Check out the master branch. Enable fix regex rbx loader. Okay, so I'm not actually sure if it's running scripts or not. Let me find it. File. Read. Load. Run scripts. I am running the scripts. It didn't find it. Don't run the scripts. Okay, we got to rebuild it again. This time without running the scripts. I'm trying to show you what happens when I don't run the scripts. Ah! Surely, this time. Okay, I'm running the game engine and it's converting a Roblox map on the fly. Yay! Okay, this is what I expected to see. So you can see that when I don't run the scripts, there's these blue things here, and there's these like green things here. So this is how the map looks in like Roblox Studio when the map maker was working on it. They have these like objects to implement various map behaviors. Like this object. What it does is it sets your spawn location. So like if I fall into this trigger, I teleport back towards this to the beginning of the map. So if I go back to where I was, so now if I touch that surface, it updates my progress through the map. Touch, and if I fall here, now I spawn right there. Because I have made progress, it like saves my progress kind of. But it's supposed to be hidden by a script when the map loads. But if those scripts don't run, the map looks like this. So then running the scripts, I already have the version where the scripts have already run, sets the transparency to false before the map converts to the format that the game engine understands, and it looks correct, right? So the blue boxes are gone and the green boxes are gone. That's why I'm running the scripts. It's mostly like cleaning up the map before it loads. Ugh. Wow, 3,000 FPS, huh? Full screen only 1,000 FPS. Only 1,000 FPS. It's what a shame. Really lacking in performance. All right, so that's what's going on under the hood with the Roblox emulator for my game engine. This is why it exists. It's just to run the scripts, and it mutates the place, and then fantastic. Load failure mode. I have all sorts of cool stuff. Oh. What was I working on? Oh, yeah. I love explaining things. It's because the project is so interesting. And, like, I've already done so much work. So, like, if you have a question about what's going on, then, like, I know everything. I can just explain it. It's so fun. I know everything, all top to bottom, all the way down. There's no floor where it's not like, I don't know what happens. The Roblox engine handles that. No. My engine handles everything. I know everything that's going on. No. All right. So it didn't find that. That's okay. Why is this here? I don't think that's correct. Oh, no, that is correct. Never mind. Okay, physics, graphics. We're not looking at physics. We're looking at graphics. Graphics. But mostly just the shader. I think that all of the external stuff is done, and I just need to, like, make the shader work. So what the heck is going on right now? What am I about to try to do? All right, let's rebuild the game engine. Thank goodness for incremental builds. So we're going to load Arcane. Okay, so the red stuff is my debug visualizer. What's it doing? It is graphics code that displays the face, edge, or vertex containing the closest point to the character. So what it's saying is that that face contains the closest point to me. So it's saying like, it's saying like that red circle is the closest point on that mesh to me. So if I go over here, then it's supposed to like highlight the edge here, but I haven't written that yet. That's what I'm writing. That's what I'm making. So I'm trying to make a thing that makes like a sort of bike chain shape. So like if we look at this one, if I get close to here, so this would be like big, and then like if we look down that way, there's the other side. So it's supposed to highlight this entire edge, but I can like make it like shaped like a trapezoid. with two rounded edges. Like this. Oh my God. So it'll be rounded on this side, trapezoid, rounded on that side. And like, I'm just going to kind of do it bad at first, and then I'll try to like smooth out the tangent lines after. So that's my battle plan. That's my game plan. So what the heck? What the heck? What the heck? What the heck? Debug vert. So this one is the one that generates the circle. So this is a mesh shader. So it's like, oh, generate a mesh. And it's like, all right, so I'm going to make a mesh with n vertices, corners, and n minus 2 faces. And so that's basically generating a circle. Oh, it's a circle. It's a circle. So I generate a big triangle. Why don't I make it like this? Big triangle. And then I generate smaller triangles. Duh, 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 duh. I'm actually generating a good circle. And then smaller triangles. Duh, 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 duh. That's how it works. That's how it's generating a circle. So that's what this does. It's a circle with 24 vertices. So 24 with 22 faces. So here it's generating the points in a circle. You can see cosine and sine. And then I'm kind of like hacking it and doing 4 at once. So it like, it's generating like, it's generating like 1/4, and then it just copies that to here, copies it to here, copies it to here. So this is like, that's what's going on there. So it's generating the points in a circle. And then this is the big triangle. That's like the big triangle in the middle there. And then this is the like infill triangles that are like filling out the circle. And it's a little bit complicated, but it just does that. And then here's our bike chain. So I have the world position of one of the vertices, the left side, let's say, and then the world position of the other vertex, and I have to draw around that. That's the goal. So then I calculate the screen positions, and then I'm doing the same trick. So I'm going like around the edges, and then I'll just fill in like this. All right. So you see this, it's just negative, but like, so this is at V0, and then this is at V1, and they point in opposite directions. Positive, negative, positive, negative. And it just goes. Cool. Wow. Wow. Whoa. And then, so in the diagram, this is the big triangle, and this is the big triangle. So that corresponds to this triangle and this triangle. These are the big triangle that's in the middle of the circle. And then the big triangle between the circles is these ones right here. I guess I can like highlight this, that triangle and that triangle. Those are the big triangles in between. I haven't drawn them yet. That's to do. So that's why there's nothing between them. And then this is the infill, which is clearly wrong. Yeah. So I have to fix it. Yeah. I just love how it grows and shrinks and it like inhabits the world. It's so fun. All right. How do you make particles in Unity? I actually haven't used Unity before. I don't know. I jumped straight into making my own engine. I don't have a particle system in my engine. I might make one. I think it'll be cool. But like that's several years down the line. I have so much other things to do. Like making it so you don't fall through the ground. Look at this. This is one of the bugs I'm trying to fix. So if I like sneak up to the edge here, I just kind of fall through. And I can just kind of fall through in other ways as well. Yeah, just fall through the ground. Does your engine have neon? You mean like a shader? No, my stuff is very, very simple graphically. This is actually all of the shader code in the entire engine. There's a total of 250 lines of shader code. So it's very simple. I'm mostly working on game mechanics. Like you saw me like jumping around. So I've mostly been working on like the physics, making it so that you can jump on things, and the game mechanics, like strafing to gain speed, and like you land on a spawn, fall in a trigger, you get teleported to the previous spawn. That's what I've been working on, is like the game mechanics themselves. My goal is to fix falling through the ground bugs by the end of the year. Very, very difficult. It's really, really complicated. Yeah, you can't jump on this. Maybe make more raycasts that prevent it. I'm not using raycasts for physics. I'm trying to make an incredibly robust physics system. So raycasting is a very brittle unit of computation to use for physics. If you use raycasting, so like you could imagine implementing a tank or a car or something with 4 raycasts. There's so many ways that fails. So what I'm using is actually mesh tracing. So instead of a single point and tracing a single point, it has a mesh. And it traces out the shape of the mesh. So like if it collides here, it's like, yes, that's the collision. And then it can also detect if it's like on the side. It's like a thick ray. And the thickness is a mesh. You can imagine that's a lot more complicated. Unity has a box cast. Yeah, the Roblox has shape casts as well. But I definitely try to avoid raycasting for making robust game stuff. Raycasting is incredibly easy to design a failure mode, a failure case. Like you can just walk into the side of your car wheel, and then the wheel goes like this. That's what I mean by it's brittle. Okay, so am I going to figure out why this is wrong, or am I going to try to... So what is this? Step. Step is n over 2 over count. So this is 12. Count is 6. So 12 divided by 6, step is 2. So it's trying to make small triangles. 2. 2. I times 2. I is from 0 to 5. Step by 2. So it's saying 0, 1, 2, 2, 3, 4, 4, 5, 6, 6, 7, 8, 8, 9, 10, 10, 11, 12. That's 6. And then add, loop, divide by 2. Count is now 3. Oh, that's not. Oh. It'll break on the last loop. Uh, 0 layers. Am I tripping? Could I just like do the big triangle like this? Step 1. It's n over 3. But like the count should be like that. Like, okay. Okay, so count is 24, 12. Another loop goes by 6. Another loop goes by 3. What if I go another loop? What happens? So this is now 1, which is like wrong. Okay. So step is n divided by 1. So step is 24. 24. So I goes from 0 to 1. Step is 24. No. It's going to try and make a triangle here, here, here. And that's not going to work. Okay, I was just wondering if I could like remove this and add another loop to the list. Okay. I think it actually might work for this though. I think I could remove these triangles because it would go like here, here, here. Okay, so this is 12. It's complicated. Why did it make it so complicated? $12, 6. 12 divided by 6 is 2. 2 at a time. 6. It does 6 polygons. Fantastic. Base plus I, P plus base plus I. 2 at once. Amazing. Amazing. Yeah. I want to see it up close again. So this one is like, that one is like aligned to the triangle, and then it just gives up. And then this one up here is like not aligned to the triangle. It's got like a big one there, a big one there, and a big one there. The triangle is right. I got the two triangles perfectly correct. Two. I have to do two. 12. There's 12. No, there's 13 vertices. Uh, oh, I didn't notice. Look at that. There's actually a vertex here, vertex here, vertex here, vertex there. So it has one triangle here, 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 and then triangle here, 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 and a triangle here, here, here. So it's actually it's done two layers correctly. So it's done the outer layer and then one layer in, and then it broke. Yeah, no, it shouldn't be doing 6. It should be doing 4. Like this song. Huh. 4, 4. But there's not. That's the Oh. Okay, so like the entire thing is big wrong. Big wrong. N. We don't want 3. We want like 2. I can change it. Okay. Did I just fix it? Mm-hmm. Oh, oh, yeah. Look. It's double covered the inner triangle. I think I can actually just drop these because I think that the last iteration of this loop just generates these fine. Oh. Let's try it. Let's try it. 0. 0? I guess we can do 1 and do the big ones as 0 and P. That would be easiest, I think. Oh my gosh. So okay, what are the indices of the big triangles between? So it's 0, 13, 14, 26. So, 0, 13. 13 is 13n? No. 13 it's n divided by 2. And then this one is n divided 2 plus 1. And then this one is the same but shifted. And that's the final form.
Did I do it? Did I do it?
Please work. Do you do everything in release mode? It's too slow when you're not in release mode. Maybe not anymore, actually. This, like, significantly optimizes. Oh, what's going on there? Huh. Oh, I've forgotten to set one of the vertices, so it's just kind of pointing out my cursor. So one of the vertices is sitting at 0 on the middle of the screen. So it's just connecting a triangle to 0. Huh. That's interesting. Interesting. I really like that this handles the big triangles. I totally would have tried to do that in the other one as well. It doesn't need to be a special case. That's pretty neato. Oh, I'm talking about this one. Base equals 1. 0. So this is the between ones. Huh? Yeah, so it skips that one. Okay, I said, what is this? I don't like it. Where was I? Okay, 0, 13, 14, 26. We need 14, 26, 0. 0. So this is actually massively wrong. This needs to be 0. Let's just do that. N plus 1. Well, I'll do the full math. N over 2 plus n over, oh, hail. Plus n over 2 plus 1, 0. So I was referencing a vertex that doesn't exist. Hey! This time. It'll work. Definitely. Yeah, it'll work. Yeah, it'll work. Yeah. Ooh. Okay, so it's big time highlight. Ooh, doesn't that look nice? Look at how it, like, it looks like it's inhabiting the world. It'll fall apart in a second. Watch this. Is that Roblox? No, this is a custom game engine that I wrote from scratch. It works decent. You can't really tell. Why are the infill triangle's broken. Is there a leak? Is there a no? It's only one loop. +1. All of the vertices should be triangle local. N over 2 plus 1. N is 24. Oh, it's not 24. Oh, right. I made it 8. It is now 8. N is now 8. Is this so you can see the collision boxes? This is so that I can debug my algorithms. So what's going on? There's a lot that's going on. I have my wording here. So this is displaying the face, edge, or vertex on the mesh under the cursor. The cursor is like sitting at the center of the screen. It's highlighting where the closest point on the mesh is to me. So right now, if I just find the closest point on the mesh to me, it's going to be on that plane. And then if I go up here, it's going to be it's going to be on this edge, right? The closest point on the mesh to me is on that edge. And then if I go to the corner, the closest point on that mesh to me is at the corner. So that's what this is for. It's to highlight a face, edge, or vertex. And I'm trying to make this edge shape work correctly. You can see it's like not working correctly. The algorithm seems to work fantastic, though. I kind of wanted it to... Huh. So the fact that the line was there was a bug. You should make it so you can hot swap the shaders. The problem with that is then I have to ship the shaders. I think I'd rather just include the shaders in the binary. It's not that big of a deal. Could do it. Oh, physics bug. That's the bug I'm trying to fix. If you hit the edge dead on, so like if you land like this, you fall through it. But you shouldn't. You shouldn't. And so I'm using this to... I plan to use this to visualize the physics algorithm running so I can look at it and go, oh, that's wrong, and then fix it. Because like it's really hard to visualize. I just have to kind of like think about it and guess. Whereas if I could see it, I could just go, oh, it's doing that wrong. Because like the face crawler algorithm is complicated. So, yeah, I'm making a debug visualization so that I can debug my physics. Have you tried recording your physics state in a file? B. Oh, it doesn't, I thought it would work. I don't know why it doesn't ray trace from the replay. How do I save it? I think it's N. Finish writing bot file. And then I can go like bot file. I forget where it's saved. Ah, crap. Is this simulating or just replaying the positions? Excellent question. Excellent question. So in my old game, the Roblox B-Hop game, it was just replaying the positions. But this time, I'm re-simulating the physics. All right, where is it saving the file? Oh, yeah, it's in the session. I forgot. Actually, it should be right here, right? What? No, don't run. Replays. Okay, I should have... Replays. Okay, I'm gonna need to list the replays by date. What's the newest one? June, December. There it is. So is this one? Replays. That one. This should exactly load the replay that I just saved. What do the replays look like? Well, they're binary files, so where are they? Where am I? I'm here? Yes. Strafe project, tools, replays. Which one was it? 300. Good. 79. So the replay I just saved is 7.3 megabytes. It's pretty big. If time step equals this, then a certain bug about to happen. Yeah, it's hard to hook it like that. You're right that it could be done, and it would be great for crashes. So if the game crashes, then I can perfectly recreate the game state right before it crashes and watch it crash. Fantastic. But for debugging the physics, I need to know the internal state of the physics. And the best way to do that is to visualize the internal state of the physics. So how the physics works is you can, it's like tracing the closest point projected onto the surface of the mesh. So there's a point that's traveling through space along a parabola, and it's tracking the closest point along the surface to that point on the path. And if the point on the path intersects with the point on the surface, then you know that it's collided. That's how the algorithm works. So it's finding the timestamp of the next transition onto an edge. So you're on a face. This is the face crawler algorithm. Where is the next transition? You start on a face. The closest point is moving up. It's going to hit an edge. So you're on a face. We need to iterate over the face edges. So there's 4 edges on the face, and see which one of them you're going to hit. So here's the edge vertices. We do a polynomial solve, degree 2 polynomial parabola. What is it called? The something equation. I don't remember what it's called. But it solves when the closest point hits that edge. And then it has to be within the time bounds. So the next transition has a lower time bound and an upper time bound. So if you came, it can know that it can't be in the past, and it can't be beyond the time limit of the current game step. So it just checks the time bounds. It also checks, are you going through the transition surface in the correct direction. So like if you're going into the surface, it doesn't count. You have to be going out of the surface to transition from a face to an edge. And then boom, it hits. Oh, I'm actually looking at the wrong code. Boom, it hits. It transitions from a face to an edge. And then now you're on an edge and like it detects, are you going to go onto a vertex or are you going to go back down onto an edge or a face? It's very complicated. This is some advanced stuff. I always just use AABBs and call it a day. That's what I was using before. Yeah. As I was developing this, that's what I did first 2 years ago. Oh, it looped. The bot looped. I can like, did I pause it? I did pause it. Wait, enter is pause? What? I can also skip ahead. You can see the FPS drop when I skip ahead. I can also play it faster. Faster, faster, faster. Go, go, go. Slower. Slower, slower. Skip ahead. So cool. What's your tick rate? Tickless. There is no tick rate. Things happen when they happen. It's a recipe for disaster. Oh yeah, I've had time travel bugs where you like, the game is like, oh yeah, you hit that part 3 seconds ago. And you go, you're absolutely right. Ticks make life 100 times better. So this game is a precision movement game. And I think that's the best way to do it. So imagine this. Imagine you're going 1 billion units per second. And there's this like obstacle course. So you're going like this. And there's a bunch of objects in the way like this, like this, like this, like this. And so you're going to go like... But if you have a tick rate, it's just going to go like... You're just going to go through everything. You'll just teleport to the other side, and it's like they don't exist. Or maybe you hit one of them, and then it doesn't handle the other ones. So really what it should do is it should advance time to this, handle this collision, continue advancing time, handle this collision, continue advancing time, handle this collision, continuing speed limits. No. We don't do limits. We've seen timestamp ticks and they suck ass. So CS2 is not tickless. It just has kind of extended ticks. Actually, my B-Hop game is the same way. I have a fixed tick rate and then kind of like sub ticks. I can't remember if I did it before CS2 came out. I think it was around the same time, and I was like, oh my God. I disagree. I really like this architecture. I'll show you the API. It's really cool. I do agree that it's easy to break and it's bad for like rapid iteration and like making a big fat game full of like, I don't know, hero shooter with abilities. Rust would be terrible for that because like it's really, really rigid and locked in with whatever game design is. You can't just like have things that are like mutating state everywhere. You'd have to redesign the game every time you add a new ability. But I already know what game I'm making. So this is the thing that does the tickless thing. So so you talked about saving a replay. I call those instructions. So the physics has an instruction. Wait. Oh yeah. This is the inputs to the physics. So maybe the mouse moved. Maybe you pressed a key, like you're moving right, you're moving up, back, left. Maybe you're trying to reset to the start. Maybe you're flying, toggling the fly mode and stuff. Instruction seems like CMDs, but this is so an instruction has a timestamp and then the enum of the instruction, and the replay is simply a series of timed instructions. And that's it, right? That is the only way to instruct the physics how to operate. Well, let's go look at the physics. Physics. So the physics receives those external instructions. Where is it? Physics. Instruction? No. Physics. Did I not? All right, whatever. So that thing I showed you before with the mouse and the key presses and the flying and stuff, that exists. But the physics also has internal instructions. So you started colliding with something, you stopped colliding with something, and this is actually a fixed tick rate. The strafe ticks, that's like the air strafing. And then there's one more, reach walk target velocity. So that's like two things. Why is it? Oh no, okay. So there's two things. Reach walk target velocity. So if I start walking and then I reach my top speed, top speed, that's I reach the walk target velocity. But it's also when I try to stop walking and I'm like losing speed and then I reach zero. That's also a reach target velocity. So all of this is implemented with analytic state continuation. So when I instruct the physics, it does an atomic update. And then if I don't have any inputs, the physics just evolves analytically according to whatever state it left off of. So like if I jump off the edge here, that's one state. And then the rendering is just extrapolating the current state until there's an internal physics instruction, which is pretty cool, right? Tickless. You're just going along the parabola curve. Yes. So the parabola is represented with this body object, which has position, velocity, acceleration, and the start time. And it just goes. It's cool as hell. You're so right though. You're so right that it's so easy to mess up. 100% a disaster. But it's working. Yeah, if I return the wrong... Okay, yeah, and I have this... This is a ridiculous object. Don't look at this. No. Ratio, oh my god. Oh my god. Yeah, this is a giant ball of code. Multiplayer may also prove issues with this tickless thing. It can be reconciled. You can have rollback networking. In fact... This is exactly rollback networking already. All I need to do is remember a past state and replay the instructions. It's like 90% of rollback networking is already implemented. At what rate do you send and receive instructions? Whatever rate you want, really. You could send every single one. Okay. So you know how the mouse polling rate is 1,000 hertz? I am running a physics tick for every input instruction. So this FPS, this is running at 1,500 FPS. That's just the graphical frames, and those also invoke a physics tick. So the physics is catching up to whatever timestamp the input instruction gives it. So let's go look at this. Where is this? Atomic internal instruction. So it mutates the current state. It has an immutable reference to the like models that exist in the world and the like bounding volume hierarchy. And then it receives a timed instruction. So time instruction. And the instruction is internal instruction. So you collided with something, or you reached your walk target velocity, or you stopped colliding with something. And it's the job of this function to update the internal state according to that instruction. Oh my God. So it advances the body to the time of the instruction. So that's the extrapolation. And then now you're like at the surface. So like imagine it was a collision start instruction. So like it was like, oh, in 4 seconds we're gonna hit this. Run that instruction. So it goes like update the body position. So before this, you're over here. After this, you're over here. Okay, so now you're contacting the surface. So match instruction. It was a collision start. Okay. So then there's 2 types of collisions. There's intersection objects, which is like a zone that you can just be inside. Or there is contacts. Oops. So contacts, you can't go inside of a contact because it's a physical object. Whereas like a start zone, you can go inside. So that's what these 2 cases are. Okay, so I'm immediately calling collision start contact. Good God. Let's go to that function. Wow. Okay, so we insert a new contact. You're starting touching this object. Surfing, do nothing. This is not implemented. Ladders, okay, there's ladders. Yeah, right. So there's a lot of things that happen. You might think, well, maybe you don't need all this. But like if you start touching an object, maybe you land on it and the move state changes from going into the air to walking. Maybe, well, definitely you're going to change your velocity, right? You're hitting something. What about the mode state? Maybe you hit a stage. Maybe you reach the next stage when you touched it. You're going to be touching a new object. This is a list of objects you're touching. Maybe you hit some sort of anti-cheat object and your run needs to be flagged. So these are all the mutable objects that need to change. And then these are all the immutable objects that need to be referenced to like reconcile what's going on here. Good luck, brother. Multiplayer will be testing your patience. I understand. So I'll show you my other game. Oh, can I go here? No, I can't go there. All right, I'm just going to close this. Go away. Go away. Discard. Roblox. So actually, I have an advantage. Roblox. Oh my God. I have an advantage for multiplayer because my game is like single player. People can't bump into each other. So like, oh my God, that immediately solves so many problems with multiplayer. So I have it easy. But there's still like replication and stuff. And I am doing server authoritative physics on my Roblox game. I'd hope a surf game doesn't have collision. Yeah. any day. Is Roblox going to work today? Usually it works. Roblox breaks itself every once in a while. Wow, it works. Okay, so this is the game that exists, and with people playing. I made this game on Roblox, so it's the same game, exactly the same game that I'm just making again. And I have multiplayer where you can like see people playing the map. So I have made a game before, and I'm just making things hard for myself by writing my own game engine. But it's not because I want to make a game. That would be a bad reason to make a game engine. It's because I want to learn about how to make a game engine. That's really the only reason why you would make a game engine. It's because I think it's interesting and I want to learn. I also like want control and to be able to fix any bug that comes up because I have control over the entire stack. I think that's really cool. So the game engine is like my vision of a perfect game. And I'm designing every component by asking the question, what would be the best possible design for this game? So I think that the tickless physics is the best possible design for this very fast-paced movement game because people could make maps where you go at 1 billion units per second. And and it would still work. It would correctly handle like what I want from it is that it does what you expect it to do, right? So like if I'm flying around really fast, if I like am flying into this corner, what I expect to happen is I hit the wall and then I hit the corner and then I start falling. And like what happens is it did 2 collisions, wall, corner, and then started falling. And it did that at sub-tick precision, in the correct order, and like kept running the tick until it completed and like handled each collision in order. That's my like idea is I want people to trust that the game does what they think it does. And it's like intuitively doing things correctly. Does Roblox use ticks? It doesn't matter. I have my own layer on top of this. I wrote a custom physics engine in Roblox as well, in Lua. I'm not using Roblox physics for this. Here's the fastest player. World records are awesome. Forgot it uses Lua. So my friend wrote a algorithm to determine when 2 convex meshes are intersecting. He didn't realize it, but it was GJK, which already exists. He invented it from scratch. And he was like, Reese, you got to rewrite bhop now. And I was like, oh, I got to rewrite bhop now. So I spent 2 years rewriting this game, years 2020 through 2022. And this is the result. This is the outcome. So in the old version of the game, it was just naive physics where like you just teleport to the next tick location and then check to see if you're intersecting with anything, and then they like push out if you're intersected with anything. And the new version is the like, it's kind of like hybrid tickless. It's bad, where it's tracing the path volume, and then if you collide with something, it handles that collision and then continues the tick until it completes. But it's still at a fixed tick rate. So in the old physics, you could be going fast enough to clip through a wall. So if I, this is no clip. I can just like freely go through walls. But if I re-enable physics, you can't go fast enough to clip through a wall in this game. You literally cannot. Actually, floating point, you never know. Oh yeah, another thing about this the strafe client, my Rust code, there's no floating point numbers. I'm not using floating point numbers. I'm all integers. I was gonna ask that. Yeah. So that was like one of the driving factors for why I wanted to have the like subtick precision. I wanted to handle each collision as it happens and make it impossible to go through walls because it's tracing the path volume that you're traveling through. Floats will be a problem for reproducing consistently. Determinism. Yeah, determinism. Exactly. Yeah. Another good reason to never use floats. Floats. Another crazy thing about this, ouch, is the problem with fixed point precision in integers is overflows, right? When you multiply two big numbers together, the result can be too big for the precision. So I invented something new again. When you multiply two numbers together, the output is a bigger number. So if you take two 64-bit numbers, the precision of the output is 128 bits. And if you take that and multiply that, the precision is 256 bits. And they take that, invented BigInt, but it's not BigInt. It's compile time verified. The types are like merged together at compile time. It's fixed size that's determined by the code. So it's not dynamic. It's stack allocated. It's stack allocated fixed point precision where the precision is determined by the operations. And it's really slow. Let's see if I can find surprise. Let's see if I can find the slow spot. Fix. You can't use SSE or AVX. I'm not to the point of like optimizing it yet. Okay, so if we go to master branch, build it. Okay, so I told you about the face crawler algorithm and how it's like transitioning onto edges and vertices. And it's like tracing the closest point across the surface of the mesh. So the problem with that's all well and good, right? How do you start the algorithm? How do you know where to start? So 2 years ago, I whipped up an algorithm to start. So like if I'm like tracing the point across this object, how do I know where to start? So what I thought of was, how about I start out at infinity? So we start at infinity, and that's really easy. We just go like, okay, that's the infinity direction. This should be closest to infinity. That vertex, we're gonna start here, and then. Now we're at infinity. We're tracing in. Yes. Okay. And then it starts transitioning. Okay, now we're going from there to there to there to there. Okay, this is the starting point. Got it. Okay, starting point. And then that's it. It does the face crawler after it traces in from infinity. So it does like 0.1 milliseconds, or usually 1 millisecond of time after tracing in infinite time. That it works though. So yeah. Where's that point? Is it over here? Oh, I can't clip through the walls. I don't have no clip. Oh my god, I forgot. Okay, I'm gonna go here. This should be faster. So this version is the master branch version, and this version is a new algorithm that determines the starting point. It directly attacks that crawling in from infinity slowness problem. So this one works quite well. So like if I go like this, I can just like parabolic mesh tracing. Let's go. Let me find the lag spot. There's a spot where you lag really bad. All right, oh, I just went through it. I just have to make my way through the map. I think it's right here. I think I have to go through here. It's over here. Oh yeah. So right here, this is the lag spot. Oh, come on. Ah, there it is. See the FPS counter? 1,500 FPS. Remember how I said it runs a physics stick for every time you move the mouse? It's faster. It used to be like 20 FPS. It drops down to 100 FPS. Takes win again. So it's so slow is because every single time to start the algorithm, it traces in from infinity and goes, traces in from infinity, traces in from infinity. Very, very slow. So it's like doing that like wide precision multiply and like transitioning vertices and like, oh my god, it's doing so much unnecessary work. And then this new algorithm, min diff, directly finds the starting point. It's a really interesting algorithm. What it does is it uses simplex, and it like crawls through the volume of the mesh towards the point. So it's like it can like have a triangle that's inside the mesh, and it forms a simplex, and then it like exhaustively proves that simplex contains the closest point, and it like travels through tetrahedrons within the mesh volume towards the closest point until it's proven that surface contains the closest point. And that's just so much faster than the like infinity thing where it like infinitely goes around the mesh. So this one doesn't have the FPS drops, the new branch, because it actually has a dedicated algorithm to start the physics algorithm. Ticks win again. No. Math wins every time. You haven't done enough math yet. I'm sure I could do like linear optimization. So like the best type of optimization is algorithmic optimization. And then once you run out of better algorithms to implement, then you can like optimize performance by a fixed factor by like using better CPU instructions and stuff, which is very hard. Let's use a nice library. So this should be good enough once the algorithm works. It should be good enough to like run at 2000 FPS on a toaster, even though it's doing a stupid amount of math for the physics with stupid wide numbers. It's stupid, but computers are fast, so it doesn't matter. So where is the inside stuff? Yeah, so I haven't mentioned this yet, but this is a Minkowski sum of two meshes. So how do you take an algorithm that's walking across the surface of one mesh and tracing a point on a parabola into mesh tracing, parabolic mesh tracing, where you're tracing a mesh across a parabola? Well, the Minkowski sum of two meshes does exactly that. You can just input the Minkowski sum, and then suddenly finding the closest point to a mesh is equivalent to finding the closest point between two meshes. What is the Minkowski sum of two meshes? So I've described it a lot of times. This is how I describe it. So imagine that there is a point in the center of this mesh, and it's tracing out a surface. So it's tracing out a new mesh. So this is like a face on that mesh. So like the point is tracing out a face, and this entire face exists outside there. And then if you continue tracing around, the center point is like tracing out a new surface around the mesh. And that's the Minkowski sum of two meshes. You can actually choose any point. It doesn't have to be the center point. But that's how it works. And so if you do the parabolic trace onto this Minkowski sum mesh, it's equivalent to doing a mesh trace. Very, very nice. So now I can think about algorithms in terms of one mesh and do it like that. But then for free, I can do it in terms of two meshes. Oh, that wasn't even the math. Oh, this is the math. So this is the Minkowski sum math. It's some of the most complicated code I've ever written for free. So I'm not pre-computing the Minkowski sum mesh. You can imagine that you could pre-calculate that mesh ahead of time, and that would work. But then you can't like have dynamic physics. So what I'm doing is like progressively querying the mesh topology of like, okay, if we're on this face, what are the edges? What are the face edges? Okay, well, that's that edge, that edge, that edge, that edge. This face has 4 edges, but it's a Minkowski face. What? Vert face, edge, edge, face vert. What? So what that means is, so I was tracing out a face before. So this is a Minkowski face. We could call it a face vert Minkowski face. But there's also edge edge. These two edges form a Minkowski face. The point within this mesh is like tracing out a face using the bounds of these two edges. So that's the edge edge. And then also there's vert face. We're using a vertex on this mesh and a face on this mesh. So those are the 3 types of Minkowski faces. And so I can like query what are the edges of that Minkowski face, and it'll like figure it out. What are the faces of this Minkowski edge? Vert edge, edge vert. And it'll figure it out. What are the verts of this edge? Very easy to figure out. What are the edges of this vert? Much harder. So I have this. It's all in the math. So I expect that somewhere in this math is a bug. I think it's right here. Please highlight all of the squares with bugs. So that's what I'm working on. I'm trying to find all the bugs by the end of the year and have like robust physics where you don't fall through the ground. Go away. Go away. Go away. Go away. Go away. Am I running the cool version? No. We want the cool version. Build the cool version. Mesh shader. Build it. Build it. Build it. Build it. So, mesh shader bike chain shape. The stream title. Oh, I closed GIMP. Excuse me. Imagine two circles, one bigger than the other, and then you have a rubber band around them. That's what I'm trying to make. I'm trying to make a shader that draws that shape. And as a debug visualizer. So like if we go up here, if we look up, you have a small circle at the top, whoosh, and then as I turn the camera, now you have a small circle at the bottom. So you can see how it's like going like that. It just looks like it inhabits the world, which is awesome. But it's not working correctly. So yeah, that's what I'm working on is this debug visualizer. And then I'm going to highlight what the current edge is on that face crawler algorithm. And then like look at it, watch it as it goes, and I should be able to watch it like bug out, and it'll tell me exactly what's going on and what's going wrong, and then I'll fix the bugs. That's my plan. That was a lot of rambling and explaining, but that's why I'm streaming. Oh. Oh. Okay. I am making a mesh shader that generates that bicycle chain mesh shape. Currently, I generate two half circles at fixed orientations. So it's one top half and one bottom half, and I need to like orient them along the edge. And I also need to figure out why this is generating wrong. Why is this doing this? Why is it? So like if we look at the mesh or the circle at the bottom there. Oh my God, bro. Stop. So the circle at the bottom has these holes in it, and I don't know why. Is there more? No. So 1, 2, 3. I think that's the 3 layers. I think that the first 2 layers. So the first layer is working. So what is a layer? God, I closed GIMP. So there is n equals 16 vertices. It should be 3, 1 shifted left by 3, which is 2 to the power of 3, which is 8 times 2 is 16. N is 16. So we're making a circle with 16 vertices, but we're splitting it in half. So we need 2 new vertices. So each half has 9 vertices. 9 and 9 make 18. So that's here, less than or equal to n divided by 2. So 0 to 8, including 0 and including 8, so 9 overall. And it generates the vertices on both. N divided by 2 plus 1. Plus I. I think that's right. And then these ones are kind of working. I want to fix this first. Let's see. So, okay, so first loop iteration. N is 16. N divided by 2, that's 8. Count is 8. 8 divided by 2, that's 4. Count is 4. N divided by 2 is 8. Divided by 4 is 2. Step is 2. We're moving up around the circle 2 vertices at a time. Why does it keep doing that? Bro. Bugging out. So we can see that in this broken thing here, 1, 2, 1, 2, 1, 2, 1, 2. So there's 9 vertices overall around the half circle, and the first layer is working. So this is drawing a triangle, 1, 2, 3. It's a small triangle with 3 vertices consecutive. And so you're moving up 2 vertices at a time. That's the first layer in this algorithm, is it's moving up by a step size of 2 with a total of 4. We can see that there's 4 triangles there. 1, 2, 3, 4. Wow. And it works. Fantastic. So then base plus equals 4. We've done the first 4 vertices, and now we're moving on to the next, not vertices, primitives, triangles. And we're moving on to the next set, the next layer. Okay, so the next loop, count equals count divided by 2. So count was 4. Now we only need to draw 2 triangles. We're trying to draw this one and this one, the missing 2 triangles. No way. So now the step size is 8 divided by 2, which is 4. We're moving up 4 vertices at a time and drawing 2 triangles. Indices, I times step. Step size is 4. I is between 0 and 1. Count. So this is 0. And then this is 0 plus 4 divided by 2, which is 2. So 0. No, step size is, you know what? 4. What? 2. 2. No, that is 2. That does make sense. We want to jump all the way to 2. Yeah, no, that makes sense. 2. So number 2. And then 0 plus 4. Number 4 is like right on the corner. Oh, God damn it. I don't see the bug. This looks correct to me. Isn't this just n? Am I stupid? Oh, it used to be not n. Okay. And I changed it. Okay. So we can actually use n here. Am I stupid? No, n. N is 8. So this means the ninth vertex. 0, 1, 2, 3, 4, 5, 6, 7, 8. 9. Nine. This is not 9. 9 is here. No, here. 8. Oh, 8? Wait. Confusing myself. N 2 times. Okay. Oh, P. P. Two times. Is it n over 2? I don't know. Just run it. Just run it. Just run it. Just try it. It'll. Why does this suck? All right, I'm just gonna like reopen this because it's bugging. Oh, I fixed it. Okay. So it's still not correct. So we can see it's like bugged like that. There's probably ones that are upside down as well. It doesn't. Oh, there it is. Haha. Upside down. Cool. Okay, I fixed it. Why was it doing like that? P. Why were some of the triangles working? P and P. All right, I'm going to define P. A number of primitives per circle. Half. And then we can use P in some places. P plus. Do I want this to be P? Yes. All right, what is this? N over 2 plus 1. OSRS. I will not be playing until January, at the very least. I am dedicated to trying to fix these bugs. All right, did I break it? Okay, can this like fix itself? Okay, it works as well as it did before. Cool. Fix it. Okay. So sign, edge shader, vert pause. Okay, I'm gonna put this comment down below, and then this is gonna be just all one big. All right, edge shader. Oops. Yeah, I'm gonna just have it one big thing. Nubmer. Okay. Good. Needless complexity. I love needless complexity. Okay, so now we have the version 1 of the edge shader. Good. So I need to have like basis vectors based on the screen difference in screen position, and then I can like have a perpendicular basis vector by just turning it by 90 degrees, and then I don't know. Oh. Okay, so this is sine cos. This is cosine situation. It knows, the compiler should know what to do. I'll just do it manually. Theta F32. Okay, GG. I kind of want to have that written here as well. Okay, so now I need basis vectors. This is kind of a linear space. I feel like it'll explode if I try to normalize a vector difference, but I'm also like really curious to see what will happen. Whatever, let's just try it. All right. Construct basis vectors. No way. Vector help is v1 minus v0. Oh, it's so complicated. And then the y-axis is xy swapped, just like this. Why don't I swizzle for funsies? So y-axis equals x-axis dot yxzw, and then y-axis dot x equals negative y-axis dot x. Is that how it is up here? Yeah. Okay. That should do it. Nice swizzle. Nice swizzle, bro. So now we have basis vectors. Now we want to construct. Oh, oops. Sure. Yeah. So let's construct an offset. So x-axis times cosine dot x plus y-axis times cosine dot x. Y. X. Y. Y. And now something will happen. And I don't know what that something is. So it's going to make a freaking huge circle. But I want to see it. Why don't I check first? Oh. Did I do that up here as well? Yeah. Oh. 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 Well, we'll see, I guess. Yeah. Surely. Yeah! Big, 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 big. Okay. So now it makes big circles. Big circles. Whoa! Okay, so obviously they're off by 90 degrees. Okay, so let's think this through. So cosine is +1 to begin, and we want that to be perpendicular to our thing. So that should really be the y-axis of what's going on here. So why don't we just call it the y-axis and then swizzle the x-axis? So y and then swizzle x. Sure, go for it. The circles might be flipped in. We'll see. I didn't think that hard. Yeah, the circles are flipped in. Gah! It's so funny. Ah! All right. So y equals -y instead of x equals -x. Or maybe it might be the other way around. I might be trolling. I think I'm trolling. Yeah, I'm trolling. So this is negative. Okay. That does mean that the y is flipped as well, or the x-axis is flipped as well. But I don't actually care about the chirality of the output polygons. I don't have backface culling turned on for it. Okay, so we have this like goofy, weird thing going on. Whoa, whoa, not sure what's going on with that. This is what I was talking about. Like when you subtract the like screen depth and then like W space vectors, it's doing something weird, and I don't know what that is. I don't know. Okay, let's try normalizing it. Is that real? Is that a real thing you can do? Yeah, okay. Normalize. Okay. And it'll do something, and I don't know what that is. It's not going to work, but that's okay. Ooh, it like... What? Whoa! It's interesting how the circles look like they're like changing perspective. It's messing with the math. It's like not really perspective. It's actually something weird. Love it. Oh my god. Are you tweaking out? The math is tweaking. This works really well. Damn. It's close to what I'm going for. So how do I subtract? I can't believe how little it matters that I'm doing it wrong. So like if I get up close and personal here, I look up. Yeah, the bike chain shape is not really coming into play here. So yeah, normalize does make it smaller, but it's like really wrong in the first place. So this includes depth information and W information. So it's in a weird, what is it called? Clip space? I think this is in clip space. Clip space is amazing for drawing polygons on the screen because it doesn't die when they go off the screen and like behind you. So you can just draw. You don't have to like worry about those edge cases. It's really awesome. How do I do this? So it's like pretty close now. I'm gonna go with this. So this is a huge freaking circle. And then this, oh, it stopped. Oh, is it Z? Yeah, okay. Is a wonky edge shader. Holy moly. That's pretty good. I could use this to debug, but I'd be distracted by the fact that it like looks wonky every single time. Okay, yeah. So subtracting two clip space coordinates is something, something, something. I wonder if I can do a weighted sum instead of this difference. I can't really because I need the direction based on the edge, which you have to subtract vectors to get that difference. That's how I'm like constructing the circle. So it's like saying this is along the edge direction, and then it's going, oh yeah, and here's a perpendicular vector as well. And it unitize it to length 1, and then I'm multiplying cos by this and sine by that. And so it's like dotting points according to the basis vectors. And then if it's pointing this way, it starts from here. And so it can only construct this half of the circle or only construct this half of the circle depending on where the edge is pointing. That's how it works. I don't know if this is the best way to do it. Well, it's definitely not the best way to do it. The best way to do it is to not use mesh shaders to draw a circle. To be completely honest. Is this wrong? This is equals. Oh, equals. No, it's not wrong. Oh, it's primitives. Right. Okay, so this is vertices and this is primitives. Okay. Oh, jeez. Are these numbers, do they make sense? 2, 1, 1, 4, 4, 2. So shouldn't this be 2 less than this? And I just kind of like have done this in a weird way. It's so interesting. It's always -2. So this is like +4, and then this is +2. Different ways of arriving at the same result. So yeah, this is if I can make this work. So the size of the offset is world coordinates. World units at the specific location. I could just divide W and get absolute. Okay. Let me run it at AI. Throw AI at it and see what it if there's some sort of standard thing that everyone does that I just don't know about, and AI's like, oh yeah, you're just supposed to do this. Oh, everyone's done this before. I'm generating a mesh to highlight an edge given the 2 end points. I'm using mesh shaders to generate. Using mesh shaders to generate a mesh to highlight an edge given the 2 endpoints. What was I trying to ask? Like, constructing constructing the basis vectors for the rounded endpoint caps is confusing. I want to like get it to spit out something standard. What is the best way to make world space offsets offsets based on the world space units in clip space. So that the edge highlighting appears to inhabit the world. Embedded the virtual world, whatever virtual, I don't know. It's a little bit of like a red herring distraction wording, but like I don't know how to phrase this. It seems to like be able to figure out what I mean most of the time, so but it's not always smart enough to have an answer.
Compute the offsets in the world space. Linear transfer for projection makes you do the heavy lifting.
If you add an offset directly in clip space, you are adding a vector that is not perspective correct. The same offset will look smaller at far distances and larger close up close. That's what I want. Like I can't do this in world space because I need the circles to always face each other. They're like two half circles, and like the inner part of them needs to always face each other. Tangent normal, binormal. You see, I don't know what that is. If you want, we want to create two circles, one at each endpoint. For every point of the circle, we need a world space position. Binormal. What the hell is a binormal? Two orthonormal vectors that lie in the plane that is perpendicular to the edge direction. Two orthonormal vectors that lie in the plane that is perpendicular. Okay, so that's just... Okay, so we have our like caps that cap off the edge of our two semicircles. And it's saying that if our edge direction is like this, then binormal and binormal perp are just two perpendicular vectors to the edge direction. It just lies in this plane somewhere, and it's a vector that points like this and a vector that points like that. In that plane, is that useful? I don't think that's useful. We want it to be... I don't think that's useful.
New world.
Yeah, that's... Oh, yeah, V1, V0 world. But you can't do that. Wait, can I... Wait. Oh! Oh, whoa. Hey. Okay, look. I can use a Euclidean point, an ideal point. Those are two different things. It's one of them. So we go like this. Delta pause. Edge dir is equal to world position minus world position. Oi. And then edge dir world is equal to that. And this, I've subtracted the from the, and so it no longer, wait, model transform. That's, I mean, this should work. I could just directly subtract these. I've the ideal point. I've subtracted the like geometric algebra ideal point unit from it. So now it's an ideal point that doesn't get translated by the mesh. God damn, it's so hard to describe. You need so much knowledge to figure this out. Edge dir screen. I think this is big better. World. Oh, it's a little bit confusing to write like this, I think. Is it confusing? Like it looks unrelated. Okay, edge dir world, edge dir screen. So now we have the good. I think it's really good, and this is a really good thing that I have here. This is correct. You can normalize this. You can't normalize this. This is wrong. That's why it was going like when I was looking at it, and it looked like weird, and it was like stretching and scaling weirdly. Would that be the forward vector of the 2 points? Exactly correct. The special sauce is is geometric algebra. Where can I look at it? Edge shader. Yes. Okay. So look at this. So look, we have a point position. There's 3 floating points: x, y, z, and then we convert that into a vector 3 with 3 components. But then we extend it into a vector 4 with the last component as 1. And this has to do with the view projection matrix and like model transform matrix. Where it ignores like translations and only does orientations. I don't know if I can explain this. I'm just gonna like write it. There's a lot of domain knowledge here. Let's see. Okay, so I have the edge direction on the screen. Hopefully some sort of weirdness that makes sense, and I can construct my basis vectors from that. But it's like normal. I don't know. Let's see what happens. What happens when I just like save it as is like that? I'm very curious. It's only been 3 hours, really? Feels like I've been working for like 5 or 6 hours. Okay, what will it look like? Let me try to guess. So I've taken the world direction, normalized it. So now it's just a vector in the world that points at the other vertex. And then I put it through the view projection matrix. So now it's like an offset in the center of the screen. I have no idea what's going to happen because like it doesn't really inhabit the world in the same way, but it should be correct. Is it going to not have depth information? No, it does still have depth information. Is it not going to have W information? I don't know. I think it'll still have W information. I actually don't know what it'll do. And I don't know if this is correct either. But let's see. Let's see what it does. Okay. So far, so good. And we look up. Okay, it's still doing the wonky stretching scaling stuff. Huh. What's going on over there? Okay, it's huge. I want it to be 1 unit, so we can do 0.5 times here, I think. It looks almost the same. I think it's not the same. Oh, it's so interesting. I wonder if it's because of this. And like... Ooh, what if I world space cross product with the camera position? I could do that on both edges. World space cross product. And then I get a different normalized vector for both. That's kind of a cop out. I don't really understand what's going on. I know that this is a correct operation to make. And I know that the Z component, the W component of this is 0. So then when it does the camera projection, it's doing it on an ideal point, i.e. like a normal vector type situation. And I don't know what happens with the depth and the W. Clearly it's still doing depth and W, and something happens. So like I could generate a point with like a bunch of cross products in world space and the camera position. I do have the camera position. Camera, hello. Camera view inverse XYZ. I think that's the position. This is just like the difference in position. From camera to screen, screen to camera, world to camera, camera to world. View inverse, third column. I need to work with matrices more. Trey is so smart with matrices. I'm just clueless. So I think it's generating some weird W information. And then I'm like double adding W. And I don't know how to make a perpendicular vector screen space. So this is correctly scaled. How about I just swizzle? I'll just take the XY and we'll deal with vec2s. And I'll just take the L and it'll look okay. Is there like a fast way to do this? Whatever, it doesn't matter. So offset plus minus. So in the other one we have 0 and 0 like this. Offset. Why don't I smoke it like this? Comma 0 0. Vec4. Buh. Sure 0 0. So it won't do any of the wonky stuff now. But the two circles are the same size, and that's just sad. Oh. Okay, so it's like okay. Oh. So this is like the W space getting freaky. I could scale it, but the point I just feel like there's like a linear way to do this, and I want to know what it is. I was hoping the AI would tell me, but come on, AI, AI, AI. So we have some W information on the edge dir. What if I just Oh, I see. Oh no, that's whack. That's whack. Yeah, no, it's super whack. Okay, so I'm not seeing the freaky folding anymore, right? So like if we look, it's not like folding space anymore. It just kind of like grows and shrinks. Yeah, it's just shrinking rather than folding. So before it looked like it was like going like this, but now it just kind of goes like that. Clip space is so cool. Yeah. Up. It's already got it. So this it zeroes itself out because it's a Euclidean point that's turning into an ideal point, geometric algebra style. So this isn't necessary. It just already does that. Yeah, the AI doesn't understand anything here. Okay, so it's doing the cross products like I said. So yeah, it's generating a offset point in world space. Is it projecting it? Offset world. P0 world, P1 world. What? Why is it? Oh. Okay, so it just projects one each. Yeah, this was exactly the idea I had. But it feels like a cop out. Never add an offset in clip space. Is that the industry knowledge that the like easy way that the like what did I what word did I use that I was trying to extract information from AI? Screen space offsets, stay in clip. Oh, derive the screen space unit vector from the edge direction. What is NDC? Normalize something coordinates. Hey, man. Times W. Is there geometric algebra? Or does it just kind of not work? Give me a theme for my map. Map what, like a B-hop map? B-hop map. Alice in Wonderland. I was thinking about clip space, view projection matrices, and I was like, okay, quaternions, and then Alice in Wonderland. Evident or allegedly, I don't know. Somebody said that Alice in Wonderland is about quaternions, and it made so little sense to the author that he made it to make fun of quaternions, and that the Mad Hatter is like the eye component, and they have like they look differently from different perspectives and stuff, and they're like not self-consistent. What did I say? Something knowledge. Situational, contextual, field, domain knowledge. That's what it's called. All right, AI, you better smarten up and write all my code for me. Otherwise, I'm gonna think about it harder. Non-linear, yeah. We need to produce a response. Oh my god, is reasoning? Clip space is not linear. Why is it linear then? Looks pretty linear to me. What is NDC? Sure. Normalized device coordinates. After perspective divide, that's divide by W, and before the viewport transform. What? There's a... I hate how it scrolls like that. Normalized device coordinates. World space, view space, clip space. And then you divide by W, and now you're in normalized device coordinates. And then... Okay, viewport transform. I'm guessing that's like where your game window is on the screen. And then you get screen space, I guess. That makes sense. Projection matrix, view matrix, world. That's clip space, like I thought. And it's a 4-vector. The W component is the depth that divided out. And that's not true. The Z component is the depth. The NDC Z component is the depth. Depth testing and culling. We love depth testing. Okay, so a really easy way to visualize clip space is like you have a camera frustum. So like me sitting in front of my monitor, there's the 4 corners of the monitor, and like that's my like viewport, and it starts at a point. It's like one eye, starts at a point, and then goes like this, and it's like a pyramid that comes out of my eye and goes through the corners of my screen. And what clip space does is it takes that pyramid and it flattens it into a cube. So at the front of the frustum, a frustum is like a pyramid with the top cut off. There's the back plane of the frustum that's like big, and then there's the like front plane of the frustum that's a small square. And what it does is it takes that like frustum and turns it into a cube from -1 to +1. The near clipping plane, the far clipping plane, and then the sides of your view frustum becomes totally flat. Just an incredible transformation. It's totally linear. Amazing. So depth is the Z component. And then the W component is like something else. It's brilliant. Yep, that's it. Okay. So NDC is what that means. That's the like weird factor. Haha, W weird. Ugh. NDC to clip. Why would you want to do that? How do you know W? It's normalized. What? .5 X. Pixel radius. Are pixels on the screen. Normalized device coordinates. I'm just like building a point on the fly. Blah, blah. It feels like a cop out. I don't want to use the camera position. It's going to be like a bunch of math, bunch of square roots, normalization, and then like. Should work though. I'm kind of defeated. I want to go eat stuff. It draws the edge. It draws the edge. I made it draw the edge. It's like not quite right, but um project ideal point is pretty cool. All right, I think I'm done. I can't believe that this is 3 hours of streaming. I feel like I've been streaming for like 6 hours. I've done 6 hours of mental work. And yapping. I did big yapping earlier. Explaining all sorts of different game engine parts. Oh, it's so awesome having the domain knowledge. I love having domain knowledge. That's why I chose to make a game engine. It's because of all of this domain knowledge that I now possess. Would know nothing if I just like built a B-Hob game in like Fortnite or something. Or in like Unreal Engine Unity. Which that's totally fine. Because like if your goal is to make a game, that's way better to make a game. But my goal is to get domain knowledge. I want to know. And now I know. Makes me really happy. All right, I'm going to like eat things and relax over the weekend. It's the weekend, right? Friday? Yeah. I'll maybe figure out the edge stuff over the weekend. I'll probably just gloss over it on Monday and try to use because like it works well enough to display the edge. I'll try to use it to debug the face crawler on Monday. Very, very good job. I get a nice pat on the back for making the edge visible. You can see it. Why don't we take it all in? All right. Show me the money. Yeah, edge. Yeah, face, edge. Yeah. Face, edge, vertex, face, edge, vertex. That's right. Yeah. No more bugged. Look at him go. Wow. 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 Ah! That's a bug. That's the bug I'm trying to fix. I think that's the bug that's holding back the new algorithm. And it's like maybe even a single bug that I can just fix. And then like we'll have like decent physics and it won't do this. I think that's exactly that bug. Oh, it's so cool. Look at it. It's very good enough. It's wrong. Oh, it's so cool. So cool. So cool. All right. I soaked it in. All right. I'll see you on Monday. Goodbye.